All right, let's get right into it. If you're an 11th grade student, you know the feeling, staring at a gigantic syllabus and wondering, where do I even begin? Well, today we're not just going to list topics. We're going to find the keys, the high weightage concepts that unlock everything else.
Yeah, this probably looks familiar. You see that long list of chapters for physics, chemistry, and maths, and it feels like you're supposed to climb a mountain but with no map. That feeling of being totally buried is completely normal, so don't worry, you are not alone.
But what if I told you the solution isn't about more all-nighters or trying to memorize every single page? Nope. The real secret is to study smarter. It's all about finding those foundational concepts, the main pillars that hold the entire subject up. You master these, and the rest of the building suddenly becomes a lot less wobbly.
Okay, let's kick things off with physics. It's this huge, incredible subject about how the universe works. But so much of it, and I mean so much, boils down to this one elegant idea: balance. So just take a look at this list. You see all the heavy hitters: kinematics, Newton's laws, work and energy. But check out what's highlighted: center of mass. Now, this is not just another topic on the list. This is the linchpin. It's the crucial point that connects so many other ideas.
So what is it really? Well, think of it as the perfect balance point. You know, if you try to balance a long, weirdly shaped object on just one finger, there's only one single spot where it won't tip over. That is its center of mass. It's the average location of all the mass in an object.
And here's the big payoff. This is why it's so important. When you truly get the center of mass, so many other things in physics just click. All those confusing problems about rotation and torque, they start to make sense. Newton's laws can suddenly be applied to a whole complicated system as if it were just one tiny dot. It simplifies everything. It's a massive shortcut.
Next up, chemistry. For this one, we're looking for its Rosetta Stone, that one key idea that lets us translate the tiny, invisible world of atoms into the real world we can actually measure in the lab.
And there it is, right at the top, the mole concept. Now I know, it might just seem like a basic calculation, but you cannot overstate how important this is. It is the absolute foundation of all quantitative chemistry, period.
So what is a mole? It's basically a chemist's version of a dozen. But instead of 12, it's a number that is just unbelievably huge. It's the bridge that connects the weight of a substance you can put on a scale to the actual number of individual atoms inside it.
And that is the number, Avogadro's constant. It's more than 600 billion trillion. I mean, it's just a mind-bogglingly huge number. And the mole concept is the brilliant tool that makes this insane scale manageable. It's pure genius.
And this just shows its power. Once you are solid on mole calculations, you unlock the ability to do everything else. We're talking stoichiometry, balancing reactions, understanding gas laws, even diving into thermodynamics. It all comes back to the mole.
And finally, let's talk about maths, the language of science. A lot of the time, the biggest challenge is dealing with numbers that are either ridiculously large or incredibly tiny. We need a tool to tame them. And that tool, as you can see highlighted right here, is the basic logarithm. You know, before we all had calculators, logarithms were the secret weapon that let scientists and engineers do unbelievably complex calculations. And today, they're still essential for understanding all sorts of relationships.
So, what is a logarithm? Well, put simply, it's just a way of counting multiplications. For example, the log base 10 of 1,000 is 3. Why? Because you have to multiply 10 by itself 3 times to get 1,000. It's this awesome mathematical trick that can turn multiplication into simple addition.
This is where their magic really shines. An exponential curve just shoots off the chart almost instantly. But a logarithmic scale, it can take a huge range of values. I'm talking from 1 all the way to 1 billion and fit it all on one single manageable graph. Think about the pH scale in chemistry or the Richter scale for earthquakes. They both use logarithms to make giant numbers understandable.
So, we've got the center of mass in physics, the mole concept in chemistry, and logarithms in maths. These aren't just random topics I picked. They are your blueprint for studying efficiently and effectively.
So here's your path to success. It's a 3-step process. First, look through your syllabus and find these pillars. The idea is that everything else connects back to. Second, really put in the effort to master them. Don't just skim them. And third, just watch what happens. You'll find that new, more complicated topics suddenly click into place because you've built a solid foundation to stand on.
Remember this:
These concepts aren't just more items to check off a list. They are the master keys. Each one you truly understand unlocks a whole series of doors down the line, making your entire learning journey so much smoother and way more successful.
So, the next time you look at your syllabus, don't just ask yourself, okay, what's next? Instead, ask, what's the most foundational concept I can master right now? Start there, and you'll be studying smarter, not just harder. Thanks for watching.